Hello, everyone. Thank you for joining us. I'm Kathy Wells for OEM Off Highway. Today's webinar, Safe, Smart, Scalable, introducing PACCAR's Generation 2 Global Vehicle Inverter, is presented by Jonah Leason, Tim Dobbins, and OEM Off Highway. Today's session is being recorded and will be available on demand this week at oemoffhighway.com. A couple of tips before we get started. Our presentation today will feature slides with live audio from our presenters. You'll note that your view within the system is customizable, so please feel free to adjust the layout and engage with different windows to meet your viewing preferences. You may submit questions for our presenters at any time during the presentation using the Q&A section on your screen, and we'll answer as many of those as possible. And last but not least, please be sure to check out the related content section for some additional information and resources there. Today's webinar is sponsored by PACCAR and will explore the key features and benefits of PACCAR's next-gen GVI, including its capabilities for mobile electrification applications across many various vehicle types and markets. PACCAR is a Fortune 250 global leader in motion and control technologies. For more than a century, the company has been enabling engineering breakthroughs that lead to a better tomorrow. Now, today's presenters are Jonah Leason and Tim Dobbins. Jonah and Tim, thank you so much for being here with us today. At this time, I'd like to officially hand over the controls to Jonah to get things.
Excellent. Well, thank you, everyone. Thank you, everyone, for joining us to learn a little bit about the GVI Gen 2 inverters. We're very excited to share this introductory presentation. Tim and I have been working alongside each other to put this presentation together, along with Derek Priver, one of our marketing geniuses. And first, we'll introduce ourselves. So Tim Dobbins has a wealth of experience in conversion of electricity, mostly rooted in the industrial world, but he has been a really great guide for me to learn about his power conversion and controlling motors with these mobile inverter products. So thank you, Tim, for joining me for this presentation.
You're most welcome, Jonah. You're most welcome. Yes, as Jonah says, I'm the inverter guy in all of this. Jonah joined us a little bit later on after we'd actually started the development of the GVI, but we're glad to have him with us. He's my applications guy. As you can see there on the screen, Jonah's been working in the commercial vehicle industry for most of his life and has a great working knowledge of electrification requirements and challenges actually in the real world, which of course is invaluable when you're developing and trying to market a new product line.
So PACCAR's got a long, thank you, Tim. PACCAR's got a long history in mobile electrification. And we've had a lot of customers that have had a lot of success with our global vehicle motor platform. And that's what we see on the timeline above. And so, most of our customers, when they're searching for a motor, they also need an inverter solution. And because of the torque density, the compact power that's available in our GVM, you know, the needs are pretty specific to that motor platform. And so throughout time, we've been providing inverter solutions that match well with that GVM motor. And so that's really how this Generation 2 was born. And what we see is, you know, we've got more than 15 years of experience in the mobile electrification space. Our Gen 1 Global Vehicle Inverter is a great inverter. It's a great platform, and it works with our motors well. But what we really wanted to do was take a clean sheet approach to this Gen 2 platform so that we could really we can control the GVM and get all of the performance and efficiency out of our motors. To do this, it really takes a village, right? And so this has been a great global collaboration. As you can see here, our electrification footprint is very broad globally. We've got teams supporting PACCAR's electrification initiatives strategically throughout the world. And what we see when we look at the technology vertical for the GVI Gen 2 specifically is that it was a global initiative where we were taking application considerations and customer considerations into account globally. But as an example, my partner here, Tim, is located in our Littlehampton, UK team, and it's a small team there, very focused on the design and testing of the GVI Gen 2 mobile inverters, but again, born from that industrial inverter experience. Another example of our technology footprint, all of our software and controls are homegrown by PACCAR, and that's from our Winnipeg team up in Canada. And I myself am a part of the Rohnert Park, California team, and we have design, we have testing, and then we're also assembling the GVI Gen 2s here in Rohnert Park, California as well. So as you can see, you know, not only is our electrification footprint really broad, we really drew upon the strengths from all of our different locations to develop this product and really own all of that technology vertical that's going into the GVI Gen 2. Why did we do that? Well, our customers, obviously, as we move into the electrification future, our customers want a world-class powertrain. They want the most performance, the most efficiency, and they also want to make sure that the inverter and motor are tuned and playing well together, and that has led a lot of our customers to demand one supplier for both the motor and inverter. And so in order to provide that world-class powertrain, PACCAR has designed and developed these from a clean sheet, as I said. And we have our second generation of global vehicle motor out now. We're getting the 310 out there, the GVM 310 frame size, Gen 2. And so really now is the time to have this Gen 2 inverter to be able to capitalize on that. But really, it's making sure that PACCAR is providing the expected motion control that we're known for, right? We're known for fluid conveyance. We're known for motion control in both the industrial and the mobile space. And so in order to support that, we needed to take special considerations for work functions or electro-hydraulic applications, while also maintaining that our customers need traction solutions as well for their mobile equipment. So some of the applications, when we talk about work, when we look on the left side, that's really work, right? So that's motion control. You're controlling a tool. You're controlling the motion of a crane or a bucket. And so that's really the work side of our electrification efforts. And then we've got traction. You know, in order for these pieces of mobile equipment to go to and fro, to be able to bulldoze or plow the field, they have to have that tractive force also. And then finally, on the right side, we've got auxiliary. So, you know, every piece of most pieces of equipment need to have compressed air, need to have hydraulic pressure to enable steering. They have air conditioners in order to maintain cabin comfort. So all those auxiliaries are also taken into consideration with the Gen 2 GVI. So this brings us to setting an expectation for our customers. And really, when we do that, we're talking about safe, smart, and scalable. And that's what we'll be talking through today. We've got a lot of material that goes into detail on how we maintain operational safety, high voltage safety, functional safety, what we've done for integration, connectivity, and efficiency, and then also how our products scale into applications, supporting our customers' broad need for product in the mobile application space. So Tim, with that, I'll hand it to you.
Okay, thank you very much, Jonah. So as Jonah just said, the three pillars, if you like, the safe, the smart, the scalable. I'm going to take safe because safety was the #1 consideration throughout the development of the GVI project. Right from the very beginning, the intent was to make something that was as safe as possible, and it actually started life with a functionally safe controller that we then built the control system around, rather than taking an inverter and then trying to bolt safety onto it afterwards. And the purpose of all of that is that really, a safe product is a reliable product, and a reliable product is a safe product. The two things go hand in hand. The safer you can make it, the better it is for everybody. Now, when I talk about safety, I'm not just talking about functional safety, like emergency stops and the things that people usually think about when I say that. We mean operational safety as well, the ability to operate in a repeatable, reliable, and predictable manner in normal use. And that protects both the machine and the operator, and also leads to longer lifetime. High voltage safety is important too. Obviously, high voltage DC is extremely dangerous, hence the big orange cables and the do not touch. And it's essential that your vehicle and machine remain completely electrically isolated from that, even in the worst case failure modes. So part of that is our CE marking. We actually went for the 61800 CE mark for low voltage electrical safety, which traditionally is seen as an industrial CE safety standard, but it's also just as applicable to off-road machinery. It doesn't have to be in a factory. It can be roaming around your construction site. It's still a machine, and it still has to have the same safety standards. We also have touch safety with the secure plug and socket connections for the motor and the power. And of course, all those connections are provided with a high voltage interlock loop, or HVAL, as it's called in the trade. And then, of course, the last one is functional safety. In this particular case, it's safe torque off. The GVR is also programmed using MISRA-C, which is an automotive standard for software creation, and it involves using a model-based design rather than a coded-based design to help eliminate those programming errors. Okay, so again, operational safety, what actually is that? What does it mean? It's all about maintaining safety in normal operation, not just when something goes wrong and you have to hit that emergency stop button. And we do this through constantly monitoring what's actually going on both inside and outside the inverter. We'll be monitoring voltage, temperature, motor current, DC ripple, which is the disturbance that you get on your DC power supply to the inverter whilst it's running, and any overload conditions that it may come across. And then we use those to be proactive. So that might mean reducing the torque of the motor to ensure that the machine keeps working rather than suddenly running out of power and shutting itself down. In that way, you avoid sudden shock failures that could occur at a critical time. It's far better to know something is going to happen and be able to react to it than it is for it to just happen and then you deal with the result. But also you need to have intelligent and proportionate reactions to those events. So if something does go wrong, make sure you make the correct, safe decision, because just switching off isn't always the safest thing to do. We also have warning systems in place, so these may be transmitted back over the CAN bus to the operator, so that the operator can see if something's getting too hot, for example, if it's overloaded, and back off themselves and not wait for the machine to do it. And then lastly, we have the ability within the software to set safe working limits at an application level, so not just the product protecting itself, but the actual application being programmed to limit current at certain temperatures or at certain speeds, so that, again, you're not overstressing the rest of the machinery, as well as the inverter and the motor. So onto the next part. I mentioned at the beginning that we started this project with a functional safety controller. And by that, I mean it has a tri-core lockstep processor, the kind of thing that you would find in a safety-rated machine controller. And all of the key functions of the inverter, so anything safety-related, power management, current control, torque control, these all take place within those safety cores, which are constantly monitoring one another and making sure that everything's operating as it should do. And in the event that anything looks out of place, it will shut itself down immediately. We're also monitoring the resolver feedback, so we know rotor position and speed of the motor. That is done in a safe way. And most important to all of this is what we call the power management IC, which is constantly monitoring the internal voltage rails, as well as the main DC bus power, and looking again for anything to go wrong. So what we end up with is, as it says there on the screen, you've got a probability of failure of less than 10 failures per billion hours of use for any of the safe parts of the software and the hardware. So we also have, of course, high voltage hardware safety. So again, I mentioned before that the CE mark for electrical safety is actually quite a tough thing to meet. You have to do a lot of testing. You have to maintain safe isolation boundaries. You have to be able to cope with many different power supplies, over voltage conditions. And in a mobile machine environment, those can be extremely variable. It's not like the industrial environment that I'm used to, where the main supply is always the same voltage and the machine is doing the same thing day in, day out. It's very different in a mobile application. So a lot of attention has been paid to designing this thing so that it's safe no matter what the extreme component actually is. We have this high voltage interlock loop, which for those of you not familiar with it, it's basically a signal that comes usually from the battery management system, but it can be an external standalone device, which passes a signal through every high voltage connector in the system. And if that loop is broken, the battery is commanded to disconnect the power immediately. So within the GVI, we take that a step further, and we also monitor that, and it can be either just a current source, or it could be a pulsed square wave, all of which is configurable. And you can configure the GVI to take its own actions. So for example, if all the power goes off, you might want it to do nothing and just power down, or you might want to take a reaction to that. And it has built-in power supplies, so that if the power does go off, it still maintains its functionality and can still make those sensible decisions about what to do. Of course, there's the power lock connectors. These were chosen to match the power lock connectors that we use on the second generation GVM motors. So you have the same connectors either side. They're keyed so that you cannot possibly plug them into the wrong place. And of course, they're touch safe at all times. And then, of course, lastly in your high voltage safety is the all-important high voltage discharge. Again, this is programmable so that you can have it take reactions either when the power goes off, or if you lose your CAN bus, for example, or it simply will do it when the power shuts down. As you can see, there's a little chart there that shows you that no matter what the voltage, it will always discharge safely within 5 seconds. And if for some reason it can't do that, say, for example, the battery hasn't disconnected and there's still high voltage power available, it will keep trying. It won't just give up and overheat and shut down. It will keep trying until such time as it does actually achieve it. And of course, all this time it's reporting that back to the main vehicle controller so you can see the state of it and maintain safety that way. Finally, on to functional safety. Achieving a safe torque off usually involves just switching off the power to the IGBTs, the little switches that are inside the inverter that generate the AC waveform for the motor. That's the normal way of doing things. However, if you've got a permanent magnet motor, such as the GVM, this is actually can be a very bad idea, because a permanent magnet motor is also a generator. The faster it goes, the more voltage it generates. So what would happen if you simply switched that off when it was running at high speed is your motor becomes a very high voltage generator, which can be very, very dangerous. So what we actually do is we actually short out those motor outputs. And in doing so, that brings the voltage across the motor outputs down to near zero. The motor is now not generating any volts, but of course there's still power in the system. So the result of that is there's lots of current comes back from the motor, and the GVI has to be able to deal with that. So lots of effort gone into that to make sure that it does that, but also makes the right decision, because you don't necessarily want it to do that when you're moving very, very slowly, because the action of doing so produces braking torque. It's all about the basic physics of things, is that if you reduce something, something else has to get bigger. And GVI is constantly monitoring this and intelligently making decisions about what it should switch on and what it should switch off. The STO itself, though, is all done purely in hardware. So although the GVI is monitoring it and deciding what to do at a software level, to maintain absolute maximum safety, there's no way the software can get it wrong. It's done in hardware, and it's test pulse tolerant. So if you're using an emergency stop relay, for example, in your machine, and it's one of those ones that sends out a square wave system for extra fault detection, it's tolerant to one of those. It has a fairly wide operating voltage range on the STO, and it will come with that all-important TUV third-party approval. And with that, I believe I'm handing back to Jonah to talk about the smarts.
All right. Thank you, Tim. So, again, answering our customers' need for a matched inverter and motor combo really, requires some smarts. It's not the most sophisticated coupling, but the faster we can get our customers to reasonable calibration, the better off they're going to be, the faster they're going to be able to spin a motor. So really that's where smart comes in. But also beyond that, we know that there's a lot of customers that are going to be integrating these motors and inverters into complex systems, and that might require some I/O. So in order to answer that, providing an I/O hub is something that we do with a lot of our controllers, a lot of our supervisory controllers. So for the GVI Gen 2, we have 5 inputs. We have a key signal input, and then we can supply 5-volt power to those analog sensors, or those to power the analog inputs, providing information back to the GVI. And then we also accept vehicle power. So again, if your vehicle's at 12 or 24 volts, it'll work. But then we can provide that 12 or 24 volts out to either a PWM signal if you need to control a fan or a pump, up to 2.5 amps. You can do that through the GVI. Similarly, we can provide 2 voltages to power, again, some kind of auxiliary, some kind of ancillary device. The efficiency is something that everybody knows is important as we work to electrify. The efficiency of an electric powertrain, you're already moving from something that's 30 to 40% efficient in the internal combustion as far as getting the energy out of the fuel, and you're now moving to something that's meant to be greater than 80% as a powertrain efficient. So the GVI Gen 2 is really designed to be broadly efficient and compensate where maybe the motor inefficiencies are. We can increase efficiency in the inverter. So generally, when people ask us, how do you model the efficiency of the GVI Gen 2, we say we model at 97% efficient. And that really, again, goes back to these powertrains need to be efficient. We need to conserve as much battery energy as possible, such that we're able to increase duty cycles, increase the amount of runtime that vehicle has on one charge. Or in small battery systems, we can actually reduce the battery size by increasing or creating or providing a high efficient electric powertrain. And so what we see here is really at the top is the inverter efficiencies, very high again. Generally they're operating up in that greater than 95, 97% range. And then the motor efficiency, and then we do a lot of testing, and we've got dynos all over the globe. We've got dynos here in Rohnert Park, California, up in New Ulm, out in Ohio, Offenburg, and other sites globally. And so we're constantly testing these powertrains, coupling the GVI Gen 2 to the GVMs, so that we can really keep that high efficiency and high performance. Now for smart and connectivity, the industry standard in the mobile world is CAN. These devices support both CAN Open and 1939. They have a broad range of configurable rates that they can support CAN. And really, when this enables us to connect to the PACCAR burst. So there, we've got a lot of products. We've got a lot of HMIs, a lot of sensors, control units. We have our own proprietary control software called iCAN. And so we wanted to make sure that these Gen 2 inverters were really placed well in the PACCAR burst, in our smart electrification sandbox. And so what you see here are a lot of the other products that PACCAR has to contribute to proof of concept development all the way up to series production. And one of the other fun things that this enables, this connectivity and the smarts within the GVI, is we can put more complex systems together. So we see like EPTOs. There, you have to monitor, you have to control, you have to provide performance and efficiency in an EPTO as an example. Some of the other products, and I wasn't necessarily aware of all of the prowess that PACCAR has in controllers and HMI and sensors, but really trying to play into that smart electrification package and ensuring that these Generation 2 global vehicle inverters are playing in our smart electrification sandbox. So then that brings us to Scalable. So we've been through safe, smart, and now Scalable. So we have 3 size variations. And when we were looking at that efficiency chart, you really have to be aware of where your performance is needed. And by having 3 sizes, then you have the ability to get the most efficiency at those performance bands that your mobile equipment operates in. And so sizing is one way that we're scalable. We'll talk through operational voltage and also control. So the 3 power sizes of the GVI, nominally at 650 volts, we have a 75 kilowatt, a 125, and a 250 kilowatt. And that allows us to cover a majority of our GVM products. Now, there are some cases where you might need 2 inverters on 1 motor if it's a very large motor, and we are working through that in some specific applications with our customers. But really, that scalability enables us to leverage that full breadth of motor capability that we have and that our customer is seeking. For voltage, we've got a high nominal or normal operating range between 200 and 750 volts. So that means that if you have we'll say 350 volt nominal battery system, you can use the same inverter as your 650 volt nominal. And so that scalability also means, say you can't package enough battery cells on your product to boost the voltage, you have to be able to operate at those lower voltage range. And so really these voltage scalability enables customers to use the same products across multiple platforms where you might have variants in batteries. The number of batteries that you can package affects the end voltage. So that scalability is really important for people that are working on, we'll say, a medium excavator and a large excavator, or a medium, a large, and an extra large excavator. They can use the same scalable products, but also the controls are common between these 3 products. So then you're leveraging a common control base, and that gives you the ability to use a range of global vehicle motors using the same inverter potentially, or you could be changing out motors and inverters and still have a common control base. And that enables scale across platforms and models. So like I said, if you have a small, medium, and large excavator, or you have a big wheel loader and a medium excavator, and you're looking to electrify those, the scalability of this product really enables that for our customers. And the last note I'll say about scalability, one of the things I've learned about PACCAR is we're really good at working with our customers to move from a proof of concept to limited series production to full series production. So that scalability and support that you need at the very beginning when you're starting your electrification product or your electrification journey, PACCAR can offer support there in the low volumes and then work with you as those volumes grow and as your electrification portfolio grows. And that's another note on scalability that we didn't make a slide for, but I thought it was important to call out. So Tim, you want to walk us through the summary here?
Okay, thanks, Jonah. So, yeah, as I always say, what presentation would be complete without somebody walking you through a bullet list on a PowerPoint slide? Sorry, but I get that job today. But it's worth doing because although we've talked a lot about the scalability, the safety functions, these kinds of good things, Sometimes you need a bullet point list just so you can capture those other little detail points that you might have missed otherwise. So first up, obviously, uniform package. This was quite important to us when we were designing this thing, to have a square box, so you don't have to try and fit it into a weird space. It's quite easy to work out how much space you need for it, and have all the connectors on one face. Very important for us. That was something that customers told us very early on when we were in the research phase for this project, that one of the hardest things is that, you know, you can see the drawing of the inverter. It's the box, you work out its size, but then you've got to work out where your cables are going to run, where your hoses are going to run, that kind of thing. We also wanted to make sure that we had two separate connectors. So you got one for the vehicle loom there on the front and one for the motor. Again, once you're when you're in the prototyping stage, you don't worry too much about these kinds of things. But when you're actually building repeat machines over and over and again, you tend to have a pre-made wiring loom, and those can get very, very complicated. So having them, so you've got one for the vehicle and one for the motor that's very quick and easy to disconnect, that's a good thing. And everything's push fit as well. There's power lock connectors for the power, there's push fit for the I/O connectors, and they come as standard with push fit VDA connectors for the coolant. But you can swap those out if you want to. And finally, on the uniform package, you'll see there that you've got screw mounting holes on the sides, plenty of them. You also have them on the bottom, so that you have many, many different options for the way you actually connect this thing in. We're not going to specify to you your bolt hole must go here. You can put different brackets on it. You can mount it upside down. Do what you want with it, basically. Next bullet point, operating range. This one obviously often throws people a little bit. But of course, batteries come in different voltages, don't they? You don't want to have to buy a different product if you've got a different battery voltage. So some machines might have a 350 volt battery, others might have a 650 volt battery. And of course, those batteries, they fully charge and they discharge, and the voltage is not the same when they're fully charged and fully discharged. So it's important to us to have a wide operating range. IP6K, 9K, is pretty much a standard for a mobile high voltage inverter these days. But of course, it's been through all of the relevant tests for that. So as well as the pressure testing for water, it's been gravel tested, it's been temperature tested, all these kinds of things, vibration tested. We have some integrated I/O on board. So one of PACCAR's specialities, of course, is hydraulic control. And one of the things that this product will be particularly good at is the control of motors, pumps, that kind of thing as a combination, which we'll come to a little bit later. So there's a little bit of I/O on board that was specially optimized for doing electrohydraulic pump control, saving you, again, that little bit of extra wiring, that little extra module that you might have to have in the system. We have dual CAN interfaces. There's one for J1939 and one for CAN open. You can program over either of them, which means you can either plug your programming tool, your PC, in separately to one of those ports, whichever one you're not using for the vehicle, or you can just connect it in via the main vehicle bus. The safety features, I've already mentioned, the high voltage interlock loop. But very importantly, and you probably won't remember it from the diagram earlier, but as well as coming in on the main power circuit, it actually goes in through the GVI, back out through the motor connector, down to the motor, through the motor's connectors, and comes back again. So again, it's another little bit of wiring that you don't have to put in the system. The GVI takes care of it for you. I mentioned before the intelligent active discharge system. So just a recap on that one. The GVI itself has its own power supply on board, so that if all the power were to fail, it uses the stored energy in the system to keep its processor alive, so that it can make those smart decisions about when to attempt to do an active discharge and keep everything safe. Sorry, there's another slide of bullet points, but this time on software. So I mentioned before the MISRA C. As I said at the time, it's an automotive standard for software programming. So instead of someone sitting down and coding all the functions, they actually draw a model of the function that they want to achieve with that software module. The MISRA C then automatically codes that, error checks it for you, and you're not allowed to manually change it. And in that way, it ensures that you can't actually put any coding errors into the thing. Everything that you have produced is safe and interacts correctly with all of the other software modules. It has a high frequency output. It can run up to 1300 hertz. It's actually 1333 hertz output. Now, unfortunately, we've had to software lock that at 590 for legal reasons, but in certain applications and with the relevant licenses, you can actually run that thing up to 1300 hertz output, which with a suitable GVM gives you 10,000 RPM. So in a traction application, that's quite valuable, being able to give you that extra turn of speed. It does that, of course, through flux weakening control of the motor. And one of the major benefits here of the GVI is that because it was developed by effectively the same team of people that developed the GVM, you don't struggle with that in the way that you do with some other inverters. It's completely seamless. PC tool. It comes with a free PC tool that is, again, optimized specifically for the use with mobile inverters. But as I say, the important thing is it's free. You can have that, and it means that you don't then have to pay PACCAR to come and configure your system for you. You don't have to take it pre-programmed. You have the facility to upgrade firmware by yourself, change the application by yourself. And that PC tool comes with different login levels as well. So there's a user level, so it's just for monitoring, looking at the scope tool, tracing during setup. But then there's a technician level for those people that are actually doing the actual commissioning, and a higher level of parameters that they can get at that you wouldn't want a normal user to be able to do. Failure recorder. So this is, again, it's kind of a safety feature, but it's also really a commissioning aid, because those of us that have worked with inverters and electronics before know that it's always that startup and commissioning phase that causes you the most problem. Once it's up and running, it's generally up and running forever. So what we have is a black box. It works exactly like it does on an aircraft. And we didn't steal that from our aerospace division. We stole a lot of the technology for this from the aerospace division, but not that one. This one actually comes from our industrial inverter, something that we at PACCAR have been doing for years. And basically what it does is it monitors all of the key parameters, your voltages, your currents, your temperatures, and you can actually add a couple of your own to that as well. It monitors them very, very quickly, but only for a short period of time. And if the inverter should trip for any reason, it records those into non-volatile memory, so you can go back and read them later, and you get a very granular view of just those last few critical seconds up to the point where something went wrong. And it really helps you when you're trying to fault find it and see what actually happened. I've mentioned before the comprehensive protection, where it's constantly monitoring, detecting what any faults that may be coming up, limiting as necessary, and ultimately protecting your machine. It operates in speed, torque, and DC voltage control mode. So speed mode is what you might expect to normally be running in, but that's normally the mode you would use if you were, for example, controlling a pump. Torque control is more your vehicle traction control mode, where the speed control is actually done by you, the driver. You press on the gas pedal, it produces torque. That's how you control the speed. The DC voltage control is the one that you would use in a generator application, where instead of having a battery that then connects to the inverter that connects to the motor, you've done it in the opposite direction. And here you're actually controlling the voltage that is produced and therefore keeping everything stable. And then, of course, I've mentioned it before, but I'm going to mention it again because it's so important to what the GVI is all about, that safety functions, that lockstep core, the hardware redundancy, that real-time operating system, the thing that makes it as operationally safe as is humanly possible. So, key markets. This is kind of a marketing slide, really. And ultimately, the value of the GVI is much the same in all of them. Whether it be a truck and bus application where you might be looking at air conditioning or traction steering, for example, material handling, which perhaps traction again, maybe hydraulic pumps or even actuators. Or as another example of the many applications for a mobile product, mining and construction. Again, pumps, traction, all the same kind of thing. So the values, yes, it's that safety again. It's a very important thing, that the wide operating voltage, but also the fact that we've tried to build in some future-ready technology. So that processor core that it's got is actually a very, very powerful thing. And although we're launching the GVI to the world today, that doesn't mean we're stopping developing it. We're going to keep working on that. We have ideas for the future for actually building in electro-hydraulic pump control, for example, and not just having the I/O, but actually having the software features involved. Cybersecurity is becoming a big thing. It's already very prevalent in the on-road automotive world, but that will spread to the off-road as well. So again, we're working on that for the future. We're trying to build something that is future ready that we can build upon and be the first of many things. And of course, as Jonah has mentioned before, that scalability, the ability to try and right-size things as much as possible. In the industrial world that I come from, it's very easy. You buy a motor of that size, an inverter of that size to do a job that size. But with mobile electrification, it is a very, very different thing. It's very difficult to try and size those components and choose the right thing for the job. So the more choice you have, the better. So I mentioned before DC voltage control. So that is what you would use in a generator hybrid system, something that the GVI GVM combination is particularly well suited for. The GVM motor, one of its key features, because of the way it's constructed, is that it is generally as efficient as a generator as it is as a motor. It's truly a bidirectional device. And because the GVI was designed specifically to work with that GVM, it's capable of very, very fast dynamic response when used in a generator application. Not quite to the point where you can go completely energy storage free. It's always a good idea to have some kind of buffer in there, but it has been done. Traction systems, this is the obvious electrification application for a motor and inverter that everybody thinks of, whether it be on-road or off-road, and having that electrically safe high-speed operations. I mentioned before about how a high-speed permanent magnet motor becomes a pure generator. You can imagine if I'm running at an output frequency of 1300 hertz and spinning at 10,000 RPM, I'm generating some quite high voltages at that point. And the GVM's ability to handle that in a safe and predictable manner is quite a big thing. Hydraulics, however, PACCAR is traditionally a hydraulics company. So we, of course, thought about that application, whether that be a complete standalone system or whether it be a hybridized system. One of the key advantages of electrifying your hydraulics is that you can decouple them from whatever diesel or main traction supply you have, which in turn means you have more control over them, but you can decentralize them as well. You're no longer tied to having the hydraulic pipes and hoses running all over the vehicle. Everything can be where you need it to be and only turning it on and off when you need it to turn on and off. Which, of course, brings me quite nicely to ePTO solutions. This is another thing that PACCAR are pleased to be able to offer now with the introduction of the GVI Gen 2. We have the motor, we have the pumps, now we have the inverter. You add into that the cooling systems and our ICANN controller. As you can see there in a little picture, we have the ability to build bespoke plug-and-play hydraulic ePTO and ePump solutions. Which is something that we're really quite excited to be able to do. It's not just a one-stop shop for a motor and inverter, but for a complete system. And with that, I shall hand back to Jonah.
Hi, yes. So just a moment of gratitude. Before we dive into questions, I wanted to take a moment to thank our electrification growth team. They've been working hard with our customers in application. Also, our electronic motion and pneumatics division, which Tim is a part of in Europe, the electronic motion and controls division that I'm a part of, and our overall motion systems group. It's been really a group effort to get these products ready to go to market, and it's really a great time to celebrate them and all the hard work that's been put into these products as we take the reins and start our marketing adventure to get the word out. So thanks to those team, and I believe that we do have some time for some questions.
Hi guys, I'll jump back on here. Yeah, first of all, congrats on the launch and great information here. We have a ton of questions to get to, so I want to make sure to put those in front of you. We'll go ahead and begin the Q&A. Let's dig in and we'll start with, let me grab. Can these inverters be used as an active front end for machines that have an umbilical cord with a direct connection to three-phase AC electrical service instead of a DC battery bank?
Oh, well, that is actually a question we get asked quite a lot. And sadly, the answer is no, you can't. It would be nice if you could, and there are a few manufacturers out there that make those. But one of the key differences with this kind of inverter is not just that it was designed to be used on a battery, but for our CE marking, we have to design we would have to design that product so that it was suitable for actual connection to the mains grid as well, which is quite a difficult thing to do. It's something that we're hopefully going to work on for the future, but unfortunately not today.
Okay, fair enough. Next question. The GVI software will this is in a question form, excuse me. The GVI software will back off torque if it deems necessary independent of the request from the machine controller?
That is true. Yes, it will. Obviously, it will tell you it's going to do that. It doesn't just do it and leave you hanging. But say, for example, your motor is getting particularly hot. Now, one of two things is going to happen. You're either going to keep on piling current into it, and it's going to overheat until the point you damage it, or the right thing to do is to back it off. So the first thing the GVI will do will give you a warning that it's going to happen. And if you don't take action yourself, it will then act to protect itself. It will do it smoothly. It won't just trip out and stop. But yes, it will back the torque off and the current off to protect both itself and the motor.
Okay, great. Thanks, Tim. Let's hit the next one. In a multiple inverter installation, must you energize the active discharge in each inverter at the same time, or could a single inverter handle the discharge from multiple inverters?
That's a good question, well, actually, something people don't often think about. Because ideally, you would turn them on all at the same time. If you think about what you're trying to do here, you've got a large amount of stored energy in your system, and you don't want to put that all through one device. It's going to struggle. The GVI will cope with it, but it isn't going to be able to do it within the 5 seconds. It will do it for as long as it can. It will have to have a little bit of a rest, and it will carry on. But really, yes, you want to try and invoke that in all of the items that are connected all at the same time, so they all share the work.
Okay, great. Next up, I see there is an STOA and STOB. Does STOA mean there are 2 wires for just that, meaning there are 4 wires total for both STOA and B?
No, there's 3. So you have a wire for STOA, a wire for STOB, and a 0-volt reference. And you can, if you don't require the full performance level D, you can just link the A and the B together and then just connect those to your auxiliary voltage. But the correct way to do it is you have a separate A, a separate B, and of course a 0 volts.
Okay. These are great, guys. Keep them coming. Next up, vibration, shock, and temperature extremes are typical in mobile transportation environments. What S and V standards have you qualified to?
So we have qualified to ISO 16750 for sprung mass. So basically a component that's mounted to a chassis, but not directly to the axle, in that there is a shock and vibration filter being the suspension of that chassis. So, and then also any, external environments, we enable coolant temperatures up to 65 C. Certain applications, we may be able to have higher coolant temperatures, and then ambient temperatures up to 65 C.
Okay, great. Thank you, Jonah. We've got a couple more lined up. Hang in there, fellas. What is the minimum logic power that will power up the low voltage circuits?
Quick and easy, 8 volts.
Done.
Brown out at 8 volts.
Yep.
Okay, good deal. Next up, you said the voltage range is up to 750. Can the inverter possibly go up to 800 or 850 for a short period of time?
So there's a question we get asked quite a lot as well. It's actually one that confuses people a little bit, because in various places we talk about battery voltage or supply voltage. And so a battery voltage range, typically we quote that as being lower. We tend to say 200 to 750. And that's because obviously if you had a 200 volt battery, when it's fully discharged, it's going to be down at 180. And if you had a 750 volt battery, that's going to be up at about 800 when it's fully charged. So the actual voltage range of your inverter is like 150 to 800, but that's for a battery range of 200 to 750. But we do top out at 800. That is our absolute limit.
Okay, great. Well, we've got a little bit of support coming in here. This attendee says 95% efficiency is impressive. Nice work. Inverters generate heat during operation. So what thermal management system is used to maintain optimal operating temperatures and prevent overheating?
Yeah, so we are water ethylene glycol cooled. We have looked at some other cooling fluids, but generally we leverage the host vehicle's typical cooling channel, and that is commonly WEG or coolant cooled.
All right, let's throw another one at you. I saw 13849 listed as a functional safety standard. Is on-road safety considered?
Oh, there's a good one. So on-road safety, you would be talking about ISO 26262. Oh, yes, has that been considered? That has been considered and tried, and yeah, we're actually surprisingly knowledgeable on that subject. But ultimately, we don't have an ISO 26262 cert on the GVI for the simple reason that unlike 13849, which has a very defined set of safety goals, 26262 doesn't. That allows the manufacturer, the person that's doing the risk assessment on the machine, to say what their safety goals are. That might be unintended torque, unintended speed. It might be voltage. There are all kinds of different goals that you can have. And it would be virtually impossible for us as a manufacturer to cover all of them and provide a certified product. But most of all is that once you've certified your product to 26262, you can't change it. So the next customer that comes along wants something slightly different. Well, sorry, we can't do it. So we decided to back off on the 26262 and have a product which, I won't say it's 26262 capable. That's not a thing. You either have 26262 or you don't. But underneath the skin, it has all of those safety protocols. It's designed the way that an on-road safe product would be, but we just weren't able to put the certification on it. That unfortunately falls to the vehicle manufacturer now.
Okay, great. Thanks for that, Tim. How about, can this inverter run as a master by itself without secondary controller?
No. It's not a supervisor.
Sorry, that was a simple answer, but it can't.
Great, one-word answers. Next up, are these in production? And excuse me, are these in production? And when will samples be available?
Yes, we've started limited series. Oh, go ahead, Sam.
Sorry, Jonah. No, carry on. You take it.
So we've started limited series production. We are taking orders. We have a little bit of a lead time on the 250 product. The 75 is in limited series production in July, but we can get prototypes of those two products. The 125 will be a close follow on that. So it just depends on what volume you need, but we're really good at figuring that out. If you're ready to go, we can be ready to support you.
Sounds good. Okay. How about next up is hydraulic oil cooling possible on the GVI Gen 2?
It's possible. It's all application dependent, and most of the time it's a pressure consideration, because even your hydraulic return pressure most of the time is higher than the system is tolerant of. There's also considerations for performance when it comes to oil cooling. Now that we've finished our validation using WEG cooling as the primary cooling source, we're hoping to get some more engineering resources to investigate oil cooling on all three of the products.
Great. So on that WEG note, I've got a question there. Do you recommend low conductivity WEG, or is standard WEG acceptable?
It's totally, the WEG circuit is totally isolated, so normal WEG is fine for this.
Okay. We've got these keep rolling in as long as you guys are up for it. We've got about 5 minutes left here. What about mineral oil or cooling motors?
The
That's a
GVMs
little
have
bit.
been. Oh.
Sorry, Jonah, you take it.
Yeah, the GVMs we have done some analysis with different cooling fluids on the GVMs, and we've had a lot of customers that have had some success with that. It really is just application dependent. You know, what's the duty cycle of the motor? What are the heat rejection needs for the performance requirements of that motor? That really is what enables us to make those decisions. And really, I mean, because everybody wants their products to be fully covered under the warranty that PACCAR is able to offer. And so that's really why we leverage our stellar application engineering teams to investigate those applications on a case-by-case basis. Typically, we won't make broad-banded comments because there's little nuances to every cooling system, but we're always willing to do some investigation for our customers.
Great. Keeping going here, is there a plan to scale the product portfolio below 75 kilowatt?
I'll take that one. Yes, but not in this form. So one of the things when you're trying to scale down the inverter is, of course, you know, at the heart of it all is your IGBT. That's the main thing. Obviously, the bigger your power switching, the more power you get out of your inverter. But there are things that don't change. The control board is going to be the same size. You still need capacitors inside it. And there comes a point when actually you would find that, for example, a 37 kilowatt version would be almost exactly the same size as the 75. You still got to get those same connectors on the front of it. So it doesn't make sense to keep downscaling using that same technology. There will be future generations of the GVI. As I mentioned, yeah, we've started something that has a core that we can build on. So in years to come, yes, there will be a smaller version, but it probably won't look exactly the same. You're also into the realm of integrated by that point as well. And then the decision comes, do you actually make very small high voltage inverters, or do you integrate them with the motors and in turn integrate them with the pumps? And that is something we're working on.
Yeah. Well,
right, I'm going to sneak in a couple more. Oh, go ahead, Jonah.
Well, we've worked with a lot of our divisions to evaluate smaller inverters. And most of that is in integration work. So EHAs or electrohydraulic actuators, linear actuators. We have looked at inverters. Obviously, electric linear actuators is something that we're looking at. So back to Tim's point, yes, we are looking at lower power domains. Most of those are going to be looking at packages that are more suitable for integration.
Well, the questions keep coming in. I'm going to try to sneak in a couple more. Is there a flow min and max rate for the cooling?
Nice easy one. Yes, there is. Minimum 10 liters per minute, maximum 20 liters per minute. Easy one.
Yeah.
All right, we have time for about one more. So I'm going to throw this out. Are you using reinforced insulation between the low voltage and high voltage system?
Even easier, yes.
Great. Okay. Well, guys, with that, unfortunately, that does it for our time today. We've got a boatload of questions still rolling in, so we'll be sure to get those in front of our presenters and package that up in kind of a Q&A format for the OEM Off-Highway website. Thank you so much to Tim and Jonah for their expert insights here today. Attendees, you'll be receiving an email from us soon with access to today's playback and presentation. But please also feel free to visit oemoffhighway.com to check out more on this topic and browse our other topics in our bank of educational webinars. But before you go, also, I want to point out one more time to check out the related content section for additional information and resources there. Thank you again to our speakers, and thank you all for taking the time to join us. This concludes today's program.
Thank you.
Thank you.